Hello, Omar. I cannot find your house. Okay, I will go.
Alhamdulillah, I found your house. Our lesson today is about rational numbers on the coordinate plane, and the objective is to graph points on the coordinate plane. We talked before about integers, and we said integers on number line consists of counting numbers 1, 2, 3, 4, and so, or we can name them positive integers, and 0, which is neither positive nor negative, and the opposite of counting numbers, which are negative integers, negative 1, negative 2, negative 3, negative 4, and so. So if you go right of 0, it's positive. If you go left of 0, it's negative. And also we studied integers vertically. Above 0, it's positive. Below 0, it's negative. So if you go up from 0, it's positive. And if you go down from 0, it's negative. Imagine you have the two axes at the same time, perpendicular on each other. The point of intersection is the origin point, and its coordinates are 0 and 0. Perpendicular means making four right angles around the intersection point. Any point on the coordinate plane represented by the ordered pair x and y, such that the first component x comes from x-axis. It means how far you went to right or left, and second component y comes from y-axis. It means how far you went up or down. To represent any point, start from the origin point 0 and 0. If x is positive, you will go right in x. If x is negative, you will go left in x. If y is positive, you will go up in y. If y is negative, you will go down in y. For example, the point negative 5 and 2. Here we have x is negative, so we'll go left. But how many units? Exactly 5 units to left, and then we'll go up 2 units. The point 3 and negative 4. Here x is positive, so you will go right in x 3 units. Then y is negative, you will go down in y 4 units. Negative 2 and negative 3. Starting from origin point, you will go 2 points to left in x. Then you will go down in y 3 units. As we said before, we name these points ordered pair because order is very important, as the point 2 and 3 not the same like the point 3 and 2. They have different locations. And notice that these two axes dividing the coordinate plane into 4 quadrants. In quadrant 1, you can find both components of any point are positive, but in quadrant 2, you can find x component is negative, but y component is positive. In quadrant 3, you can find both components of x and y are negative, but in quadrant 4, you can find x component is positive and y component is negative. For example, determine in which quadrant these points are. The point negative 2 and 5. The first component x negative and second component y positive. Of course, in quadrant 2, the point 5 and negative 2. You have the first component x is positive and second component y is negative. So we can find this point in quadrant 4. The point 3 and 7. Both components are positive, so the point 3 and 7 is in the first quadrant. The point negative 5 and negative 7. We have both components are negative, so we can find this point in quadrant 3. Notice that any point on x-axis takes the form x and 0. It means it has number at first component but 0 in second component because we didn't go up or down in y. And also, any point on y-axis takes the form 0 and y. It means the first component x is 0, as it didn't go right or left in x, just to go up or down in y. I wish you understood the lesson. Don't forget to like and share this video and subscribe to the channel. See you.